Welcome back to Applied Algebra and Trigonometry. Today we're going to be talking about, I'm going to be talking about natural logarithms. That's right, just them natural logs, none of that artificial stuff. To talk about natural logarithms, we first have to talk about the number e, or the number represented by the symbol e. It's a very interesting, it's a naturally occurring but irrational number, much like pi. But I am not going to go into a deep discussion of e. It's a very interesting number, but I have posted a couple of videos that explain the concept of the number e. I've posted them in a playlist on my YouTube channel. That channel is Rose's Hornets. However, if you Google that, you will probably wind up with videos of Derek Rose and the Charlotte Hornets. The best way to get to that is to click on the videos that I add as content to your Blackboard page. So if you want to see those extra videos, you can go there and look at the playlist. This irrational number e can be used as a base of logarithms, or it can be used as a base in an exponential format, which you now know is the anti-log, or the inverse log. However, we usually do not write log base e, just like we usually do not write log base 10. We have a special symbolism that we use. And in this case, instead of, we call the log base 10 the common log, we call the log base e the natural log, or the logarithme naturel en français. So we say the logarithm natural, which this is the real reason I write logs in cursive, so that looks a lot like 1n, but is actually ln. So this is the symbol for natural log. It means a log of base e. So e to the x becomes the natural antilog, if you want to be specific. Those are the terms you'll be hearing a lot in this video. You have a button on your calculator that is dedicated to the natural log and the natural antilog. You've already used it, but you have used it as the button that gives you an x in your formulas. However, if you look above it, you'll see capital LN, which is another way of writing it so you don't confuse it with 1n. You will also see an e to the x above that. So pushing second x on your calculator will activate the natural log, and on your screen you will see this, which looks a lot like 1n, but it is actually the natural log of whatever you choose to write after it. Just when you're finished writing, just make sure you close the parentheses. Okay, let's break our white space in two and see what happens if you hit diamond X instead. If you do that, your calculator will return e caret parenthesis, waiting for you to add something else, and that something else will become the exponent of e. So using those sequences of buttons, you should easily be able to evaluate the natural log of 5. So second x, 5, close parenthesis, and you should find that it equals 1.6094. All right, notice I'm rounding it to 4 decimal places. And I think that's what we ought to do with this, instead of going back and forth about significant digits. If you just report this to one significant digit, you report it as 2. And considering what we're doing, that's pretty far off. So let's report our natural logs to 4 decimal places after the decimal point. Okay, so what this means, it's a shorter notation than writing log base e of 5, but they are equivalent. And if we go ahead and rewrite that, 1.6094, 6,094 ten-thousandths. Now we can see what we need to do to convert this to exponential form. We have the base e to the exponent of 1.6094, there's the exponent, equals the argument. Now just remember, we rounded here. Therefore, if you check this expression in your calculator, you'll actually come up with something like 4.99981, so almost 5. A little bit of rounding error there. So remember your calculator sequence. Because I've written 3 numbers on the screen, I would like for you to take these numbers and find the natural logarithm of those given numbers. Please pause the video, take a moment, and make sure you can use your calculator properly. So you should have entered those into your calculators, and these are the answers. For the next set of problems, I would like for you to take the natural anti-logarithm of the given numbers. Again, pause the video and find the natural anti-logarithm of these 3 numbers. That is a negative 0.2385 for number 5. Notice problem 5 and see how the negative in front of 0.2385 is brought right up into the exponent. And there are your answers. Now all the properties of logarithms apply to natural logs as well. Let's look at exactly how these properties appear when we're dealing with natural logs. Now the thing to notice about this property, this equation as it's written, is we have the base of the log, and within the argument we have the same base. And then the exponent, which is what the whole log is equal to, is also the same as the exponent of the base. And what this works out to be, it's saying that the log base b of b to the x is equal to x. So if we write it in terms of a natural log, it looks like this. The natural log of e to the x equals x. And that is because there is an understood base of e there. So there we have the base of the base. Okay, we have the bases the same, and we have the exponents the same. So it does follow that pattern. So remember the natural log of e to the x equals x. And also, the base b raised to the log base b of x, that also is equal to x. Written with the natural logs, we would have e raised to the natural log of x equals x, because there's an understood, use a different color, base of e where that natural log is. Okay, we don't have to write it, but we understand it's there. So how about some examples? Okay, what about the natural log of e to the third? All right, which one of those does that look like? It looks like this one. So the natural log of e to the third is just equal to that power. Why is that? Let's take a look at why that would be. If you write this with the base e, just to make it blatantly obvious, we have a power. So we can pull the power out here. So we have 3 times the natural log of e, which we know has a base of e. So this is 3 times 1, and it does equal 3. So that shows that the rule works. When you're asked to evaluate this, your answer is 3. Okay. Another example of the other rule is example 2. E to the natural log of 5 is 5. Okay. E, let's do example 3. E to the natural log of x plus 1 equals e to the ln just brings out x plus 1. Okay? Parentheses not necessary there. What about this one? Example 4. E to the natural log of the square root of 23 and the whole thing squared. What does that equal? Well, we're going to leave that squared there for the moment. And we have e raised to the natural log of some argument. E to the natural log equals that argument. And if you square the square root of 23, you get 23. That's the answer. Let's look at another example. Let's look at 2 times the natural log of e raised to the 3x plus 1. And that binomial, the entire thing, is the exponent of e that's within the argument of the natural log. So we want to evaluate that. There are actually 2 ways to do this. Okay, at least 2 ways. So we could take 2 times and then evaluate the rest of it. The natural log of e to an exponent. Let's see, that's the first rule over here. So the natural log of e to the x is just equal to that exponent. So it's times 3x plus 1. Or, when we distribute, 6x plus 2. The other way you could think about this is you could apply the power rule. So you have 2, and you could bring this exponent out and say, well, that's 2 times 3x plus 1, and then you've only removed the exponent using the power rule, so you still have the natural log of e. Well, the natural log of e is 1. So it's 2 times the quantity 3x plus 1 times 1, or 6x plus 2. And we can also use natural logs with the change of base formula. So we can say that the log base 3 of 17 is equal to, let's change it to natural logs because they are easy to get to on your calculator, easy to use it to evaluate. So the argument goes into the numerator because, hey, it's higher on the page as we write it originally, and the base goes into the base of the fraction, the denominator of the fraction. Okay, so that's a way you can remember where to put things. The natural log of 5, base 5, okay? If you don't like working with natural logs, if you prefer common logs, you could do the change of base formula and change it to a common log which has a base 10, which, remember, we really don't have to write. The common log of the argument over the log to the same base. So in this base, it's a common log. In this case, it's a common log. And the understood base here is e. So it comes out. Okay, and if you want to go from a common log, say the common log of 8, to a base e, or a natural log, you would make it the natural log of 8 over the natural log of 10, because the argument goes up here and the understood base of 10 goes right there. And hey, only one video for today's lesson in today's section about natural logs. I will see you in class.